We are in Madrid, and I'm here with Len Chopin, the president of Cube Packaging, and we're talking about edge analytics. So, Len, why don't you tell us first what is it that you do at Cube Packaging, and how do you leverage the edge? What problems are you trying to solve?
Cube Packaging, we're an injection molder of plastic containers for the food restaurant industry, takeout markets, home meal replacements. Being a manufacturer, for us it was important to collect as much data as we can, as timely as we can, as locally as we can, to get a finger on the pulse of what's happening on the manufacturing floor. Historically, Cube, being a smaller company, didn't really embark on these sorts of things, but this past year we've invested in excess of $20 million on some state-of-the-art equipment that we really wanted to bring to the next level with utilizing some of the edge technologies and IoT infrastructure to capture that data that, again, is local at the machine and integrated with our ERP systems and basically have integrated business systems that include manufacturing.
Right, so these are injection molding machines that had a PLC, had an HMI. You were somewhat connected to some kind of historian before, or this didn't have any story?
It didn't have any story at all to it, so it's local to the machines. So a lot of the OEM manufacturers of injection molding equipment don't allow you the access to their PLCs. So what we ended up having to do for our situation was to piggyback on the PLCs with a secondary data collection device, picking up data points that they're also collecting the data from. So the piggyback approach has worked for us. Depending on the equipment manufacturer, they do allow you into their software to tap into some of the information, some of the data. But to be quite honest, there's quite a bit of information they collect that isn't really useful from an operations standpoint. So we really did just piggyback on certain data points that we wanted to collect data on, as well as have transparency to off the equipment.
So can you zoom a little bit into the type of data that you are making decision at the edge versus feeding that somewhere else for processing?
So for us, it's the name of the game in injection molding is cycle time, equipment time, uptime, downtime, all the metrics that you really want to know timely. For us, we really only want to know when things aren't going well. So we utilize the technology at the edge to let us know when things aren't going according to plan. So if the machine's not running optimally, if there's a temperature issue, temperature variations, fluctuations, we don't want to worry about the machines. We want the machines to tell us when they need us is the approach. So utilizing that sort of information to push it to us and say, we have an issue.
Yeah, I presume
prior to having an issue.
Right. Presume you had a huge team behind. You had the traditional way of trying to extract the data from the particular manufacturing of the PLC to their expensive data, software equipment, or doing a new way of doing things. Walk us to the decision. Walk our listeners to the decision that you went through, or you had your team go through.
So the OEM's PLCs, like I said, they collect thousands of data points. Our machines run at about 5.5 second cycle time. So you can imagine the amount of data that those collect over the course of 1 hour period or even a 1 minute period. For us, a lot of that information is useless. We don't need it. It's in the past. It's not current. It's not relevant. Minute to minute, things can change in the operation. So what we've decided to do is pick up the information that we needed rather than having to scroll through the 1,000 different parameters and figure out why this and this and this. We've, rethought the way that the PLCs are operating, and we skipped a lot of the information in the middle that really isn't relevant to the decision making or the reaction that we need to do. So we really streamlined the data coming off the equipment to get rid of a lot of the useless information, but information that's not relevant to give us what is relevant off of the equipment.
Sure. So what next? What else do you have in the future? What else do you plan to improve leveraging the IoT analytics?
IoT analytics. So we like to get predictive as much as we can. So there's a lot of inputs to the machines, into the processes, even in the internal OEM PLCs, that there are trends, there are seemingly unrelated data points that we would like to relate, because for us, as a manufacturer, they need different things, making containers as opposed to making an automotive part. So there's certain things that for us that we want to continue to analyze, that we can do some predictive. So we should be able to, looking at the machine parameters, the inputs, be able to determine quality. So for us, making a quality part, knowing the machine set points, run points, pressures, parameters, temperatures, should be able to give us an accurate prediction of the quality of the part coming out of that piece of equipment. So we're hoping to make that link between equipment run parameters and a finished product to also help ensure the quality, but also remove a layer of inspection that we currently have in place as well. So leverage the technology to also help reduce or assist with the manpower and the resources.
So very interesting. You're not only focused on predicting the quality of the product versus predicting the equipment. I presume that you've been doing some of the predictive maintenance.
Correct.
Now you're in the next step to make sure, hey, this is going to be within these parameters, and this is what we're guaranteeing the customers.
Correct. I mean, predictive maintenance, I guess in our journey, I've kind of moved beyond that because we do have those things in place. We do know the predictive, we know the nature of the equipment. A lot of the equipment has a lot of commonality, so we're quite comfortable in that area. For me, there's a return on investment for equipment uptime, but with the newer equipment, predictive maintenance, it is known for us. So it's the unknown for us, which is the output from the equipment. If everything is in line with production equipment, the PMs, the runtime, cycle times, we want to measure the output by measuring the inputs to the equipment, again, to ensure that quality product is coming out.
Thank you very much.